Continuing our discussion of mechanisms and test 3. The study guide that we just created said we just did an alkyne with hydroboration oxidation. That was our last video. So the next question would be an alkene with oxymercuration, demercuration. And I found one, F21 T3 Part 4, could be your question. Let's see, where's it say? If question 3 was an alkyne, then question 4 starts with an alkene and oxidation. This is it. Question 4 would be your question. This would be your question 4 that we're about to do. Could be F22 T3 Part 4, number 4. Okay. Circle the major product formed. Explain your choice. Yeah. The mechanism is going to reveal the choice. Formation. Predict the final product for the last step. Give the results for reaction with the major product only. So if one of these 4 is going to be formed, and only one, and then this chemical is going to convert it to what you say. Okay? And you got to remember this one, the mercury is not an ion yet, and you need, in chapter 6 or 7, mercury must be an ion with a plus charge. Chapter 7 is +2, but it's already written as an ion with a +2 charge in chapter 7. So you don't have to worry about making it an ion in chapter 7. Chapter 6, step 1 is to make this into an ion. You have to bust off one of the acetates. And I'll go with this one. So your first step in your mechanism is to create these 2 things, okay? One thing, O2CCH3 with a minus. You're going to need that thing. And the other thing is mercury. And just draw it downwards. That's okay. Hey, you can use that short form, OAC. Don't forget the O, because the AC has only one O in it. It's the CH3 carbonyl. That's the AC. And that's step 1. And step 2, you attack the plus mercury. Alkenes love plus mercury more than almost anything. It's the thing they love the most. Make sure that arrow goes all the way to mercury. You're going to make a special triangle this time. What kind of special triangle are we going to make? Why is it special? It looks like you draw 2 hexagons beside each other, but you don't draw the connector in the middle. There you go. Partial triangle all around. These are not dashes. They are partial bonds. There are 3 of them. HGOAC, and the plus is now shared. The beauty of this mechanism, that plus charge is delocalized. And because of that, the plus charge, this doesn't rearrange like cations, carbocation. It doesn't. So what's happening next? It's a triangle. Anytime you make a triangle, what's next? Say it again. Somebody was saying it. Backside attack using what molecule? Water. Which carbon? More substituted. It's like a. I'm starting to sound like a broken record. This is a very good thing. Just an arrow. Normally there's 2 arrows in a backside attack, but we don't have an arrow for partial bonds, so don't try. So you draw your rings. There's only one big ring, really, if you think about it. And you put an oxonium. If you put the oxonium on a wedge, then what kind of a bond does the mercury have to be on in a backside attack? Somebody said dash? I agree. Now this is a real bond. That's a dash. It's got 2 electrons in it and everything. I'm sorry? Anytime you do a backside attack on a triangle, one of the groups has to be in front and the other group's behind. Every time. Backside attack gives anti-stereoselectivity. I need to see 1 wedge and 1 dash for every anti. Yes. And this looks a lot like the third product, but I did the enantiomer of the third product. If you do this on a test, please don't redraw your molecule to make this the dash and this the wedge. Just make sure you pick the one that has the OH on the more substituted carbon on the opposite side of the ring as the mercury. So using those words, this one has it on the same side. Wrong. This one has it on the same side and the OH is on the wrong position. Wrong, wrong. That's got wrong regioselectivity because the O is in the wrong spot and the mercury is in the wrong spot, and wrong stereoselectivity. Syn instead of anti. This is the guy. OH on the more substituted carbon. Mercury on the other side of the ring. You made 50% this one, and 50% it's an enantiomer. I'm going to just pretend I drew the enantiomer. What's the base that takes this oxonium and makes it into this? Nice. He said acetate. We've got it drawn up here. I'm just going to use it. And that gives that species there. And acetic acid, if you're curious. And then the chemical does what? You're going to get the same rings. You're going to get the OH on the same spot. I'll go with the one that's pictured to the left. And where the mercury was, on the same bond will be what atom in its place? The D. Remember, opposite side. And down here, I'm just going to say 50% plus enantiomer, 50% enant gives pictured molecule. Pictured means this picture right here. I'm just trying to make it clear why it looks like the bonds were reversed. And that's a D. It doesn't look like a D. I want to make sure it looks just like a D. Remember, NaBH4 replaces mercury with a hydrogen. NaBD4, same chemical, different isotope of hydrogen. And all we have to do is explain. Provide a mechanism for a final product result. No explanation? Oh, explain. Yeah. Must include discussion of both regioselectivity and stereoselectivity. We got a point count for any of these? Oh, it's 6 points for the explain. No, it's 4. 4. That's a lot. You got to tell me why oxygen's on the more substituted carbon. That's easy. Is this part B? It's part B, right? B, OH2 attacks the C. This is a better wording than the previous one. It cuts down some words. Spends more time with a C+. That's why the O ends up on the more substituted carbon. Attacks the C that spends more time with C+. Tertiary. And the reason, because of, what's the H word that ends with an N? Nice. She said hyperconjugation. Wow, it fit. Okay. So that's the Regioselectivity. Regioselectivity. What about the stereoselectivity? Just use the magic words with the attack. Backside attack always gives anti-stereoselectivity is all I'm going to write. Backside attack always gives anti-stereoselectivity. I don't need the guy's name in the regioselectivity, the Russian guy. Don't need it. Not big on guys' names. Okay, so I have 4 points for B this time. That's a lot. You are explaining 2 things, that's why. What about D? Oh, we did that. There you go. So we're good with that one.